So hello guys, I am Kumar K. Previously I worked as SD at Amazon and Lear. So in this video we are going to solve a very important DSA question which was asked for a CTC of 75 lakh rupees to 85 lakh rupees for SD2 role in Atlassian. So guys, this problem is not available on LeetCode nor is it available in any standard DSA sheet or blind 75 on LeetCode list. So this totally new hard unseen DSA DP problem will teach you how to apply DP in a fun and interesting way. So make sure you watch it till the end so you can improve a lot. Let's now continue. Ram Ram. Ram Ram. Many people do DSA tutorials and courses but get stuck and leave in middle guys and show no real progress. So to solve this problem, we at DesiQnA have done this. We are giving daily life classes to our lovely students, separate batches for beginners versus intermediate versus advanced people in DSA. We also give personalized one-to-one mentoring to the student. Also, we daily check and track how much homework is done by the student on daily basis. So that's how the consistency gets developed in the person and they become successful. As you can see, so many selections here. Okay. We also give extra features like direct Fangam job referrals and other top product based companies job referrals, mock interviews, so you can know what mistakes you're doing and improve. Plus 850 of an hour best level DSA plus OA plus CP course, plus 24 cross 7 doubt support, plus personalized help plus guidance before your online assessments, interviews, right? LinkedIn and resume training we also give, so your LinkedIn and resume can improve. And the best and the most one of the most important thing, off campus job search training, so you can get off campus internships and jobs easily, and we help you with on campus as well. So if you want to check out our lovely program and lovely cohort, you can check the link. It will be in the document of problem analysis document of Atlassian. In the name of God, Ram Ram, this problem was asked in Atlassian SDE-2 interview. Now why are we solving this problem? So that you understand the solution to this DSA problem, for which was asked in Atlassian SD2 interview recently for a CTC of 75 lakh rupees. So you understand that these top companies for high packages and for SD1 SD2 roles, what questions are they asking these days? Apart from that, you will also understand how to practice and how to train to become better for these type of questions. Now this problem is based on dynamic programming, so it will be very very good if you go to this prerequisite course and complete the dynamic programming part from here. You can see this is my student who got selected at Google for internship two times, right, off campus, despite being from tier 3 tier 4 college. She also did lots of videos from this prerequisite course and even the main course. So what I'm trying to say is that you should complete the dynamic programming part of it. It's very very useful for you in your case. Okay. Now, guys, this is the problem which was asked. When you read this problem, you will understand it is not about solving the problem. It is mainly about understanding. Okay, it is mainly about understanding and deciphering what the question is actually trying to tell you. So they are saying that you are given an array A of size n. You can assume that array has all the non-negative elements. Okay, you can assume that. Consider any subset S of indices and let T be the indices of not chosen, which is the complement of S. The subset sum of S, let it be denoted by sum of S. A subset is called special if and only if all the indices which were not chosen, for each one of them sum of S should be greater than or equal to A of J. In other words, the total sum of the chosen elements must be at least as large as every single element that was not chosen. So guys, that's it. And then the follow-up is also there. Find, initially we just want a count of all the valid subsets. Then guys, the follow-up is find the sum of all valid subsets. Then one more follow-up is the find the sum of the product of all valid subsets. Before we dive deep, we need to do some basic analysis. It will make things easy for us. Okay. So let's try to see now which subsets are good and which subsets are not good. We will see this thing right in front of our eyes. Okay. So let's take some array. I'm thinking about some array. 2, 3, 4, Phi. Okay. I am claiming that the subset 1 comma 3 is valid. Why the subset 1 comma 3 is valid? Why? For this subset, what is sum of s? If you select index 1 and index 3, it is 2 plus 4, right? So sum of s will be a1 plus a3, right? Which will be 6. So sum of s is 6. Okay. Now this element sum of s should be greater than equal to all the other elements which were not selected. So if 1 and 3 is selected, what elements are not selected? 2 and 4 is not selected. So you need to make sure that sum of s is greater than equal to a of 2. Also you need to make sure that sum of s is greater than equal to a of 4. Sum of s should be greater than equal to a of 2 and sum of s should be greater than equal to a of 4. So what is sum of s? 6. Is 6 greater than equal to 3? Yes. Is 6 greater than equal to 4? Yes. So 1 comma 3 is a valid subset. Now guys, I want to know by your answers in the pro WhatsApp groups, did you guys understand the meaning of valid subsets? Please give me the acknowledgement in your pro WhatsApp groups. I am checking your answers. Open your pro groups like November Pro, November Beta Pro, Oct Pro and write yes sir if you understood, write no sir if you did not understand the meaning of the question. So just checking a little bit upon you nice people. Okay, so you guys understood these basic things. Okay. So guys, what is the brute force solution to this problem? The brute force solution is pretty simple. It is O of 2 raised to n. You will use the backtracking code and generate all the subsets of the array, right? 2 raised to n dot n. Once the subset is generated, the maximum size of the subset can be what? 4, no? So each subset you will travel that subset, you will calculate the sum and you will check for rest of the elements. Is this getting satisfied? Yes, then we will count that as a valid subset. I hope you guys know that for an array of size n, there are 2 raised to n subsets. So you can generate all the subsets using standard backtracking code. Okay. You can use standard backtracking and generate all the subsets, right? So it is O of 2 raised to n multiplied by n. Why? Even though you are generating each subset, after generating each subset like 1 comma 3, you need to travel the whole array again. You will travel 1 and 3 to get the sum of this and rest of the elements to know if this sum is greater than equal to rest of the elements or not. So guys, everyone tell me the time complexity of the solution in the WhatsApp groups. I'm waiting for you people for the answer. So let's see what the Kumar students are answering. Okay, fine. Good. Nice. So you guys understood that the time complexity is O of 2 raised to n into n, right? Right? So, yeah, you need to write that number also, O of 2 raised to n dot n in the groups. Only then I will know that you understood. Yeah, so Amit did it, Saptarshi and Mohit Bhandari and Bhanu Prakash. Okay. Okay, these people do understand. Great job. Yeah, Karthik and Kaushik also understands. And what about Kushagra, Anand, Srija, Razu, and Rajput? Okay. So guys, that's clear. Now what to do next? Now what to do next? Well, you just need to relax and enjoy. The problem is solved now. Really? Yes.
No, actually. So O of 2 raised to n into n will give you time TLE because na, it's very big, right? The n can be very big in the problem. Like it is not mentioned here, but the interviewer expects better from you. Okay, you can assume that n is at least less than equal to 5,000. Okay, so 2 raised to 5,000 into 5,000 is bigger than 10 raised to 8, and it will cause issues for you. But now, guys, comes the observation. So please write the observation in the group. The first observation, which we will write in the document as well, is very, very simple. The first observation is you are saying that you want the sum of the valid subset to be greater than equal to Aj, where J is nothing but belonging to set T. T is what? T is complement of S. All the indices which are not included in S, right? You want this to happen. This is nothing but same as sum of S should be greater than equal to maximum of all possible ages in the set T. You want what? You wanted this sum of S to be greater than second element and fourth element. That is nothing but maximum of second element and fourth element. Why? Because if sum of S is maximum, sum of S is greater than equal to maximum of the remaining elements, then it will be obviously greater than equal to rest of the elements as well. It's a common sense. So guys, this is the first observation. You quickly write it down here, that sum of S should be greater than equal to max of Aj, such that J belongs to set T. Okay? Okay, this thing is clear to you. Next thing. This thing is clear to you, so not talking in detail about it. Okay? This is clear. Such that J belongs to set T. Now, guys, there is one more big observation, and that solves the whole problem. This basically means that the sum of the subsets, see, it's laughable, but this is the solution. This basically means that whatever subset sum you are selecting, it should be greater than y, where y is nothing but the largest element in the array. No, full problem solved. Now all you have to do is find the number of subsets in the array whose sum is greater than equal to y, and y is a fixed number which is the largest element in the array. Now some people might be saying, sir, how can you prove it? Okay, I will prove it to you. See, let's say this array is sorted array. Let's say we sort the array. Okay, you sort the array. So now it's looking like what? A1 less than equal to A2 less than equal to A3 less than equal to AN. AN is the biggest element. Okay. Now let's say I choose the subset I comma j. Okay, I comma j, where my I is 2 and my j is 3. My I is 2 and my j is 3. So now what is going to happen? This will be valid if and only if a of 2 plus a of 3 is greater than equal to maximum of pending elements, right? A2 plus A3 should be greater than equal to A1 as well as A4 as well as all the elements till an, but not A2 and A3. Okay. A2 plus A3 should be greater than equal to A1 and should also be greater than equal to A4, A5, AN. But you know that AN is the largest element, right? So you don't need to check the other elements. A2 plus A3 should be greater than equal to AN. Because if A2 plus A3 is greater than equal to AN, it will surely be greater than equal to A of n minus 1, A of n minus 2, n minus 3, because they are smaller than that. तो जब आपको एक एक से ग्रेटर देन इक्वल टू चेक करना ही है, तो जो सबसे बड़ा वाला है पहले उससे ग्रेटर देन इक्वल टू बन जाओ, बाकी वाले ऐसे ही हो जाएंगे. ये वही हुआ कि डीएसए में बहुत हार्ड क्वेश्चन कर लो तो इजी वाले क्वेश्चन, छुटपुट वाला वो ऐसे ही हो जाएगा, लव बबल ड्राइवर शीट वाला. समझे बात को? So this basically means that A2 plus A3 just needs to be greater than equal to AN, where AN is the largest element of the array. So guys, our theorem is valid whenever our subset is selected in such a manner such that I comma j can be any index, like there can be many more indices. I have taken a simple subset of size 2. Subset can have size 3, 4, 5, 6 also. This theorem works whenever we have selected a subset I1, I2, Ik, where none of these I1, I2 till Ik is equal to, all are not equal to n. Whatever subset you select, last element you should not select in that subset. So guys, you select anything. Let's say you select A1, A2, A3. What does that mean? That means that A1 plus A2 plus A3 should be greater than or equal to rest of the elements. What is the largest element in the rest of the elements? An. Low. So whenever you select a subset 1, 2, 3 or 1, 2 or 5, 6 or 7, 8, where n is not included, this theorem is true. The sum of the subset should be greater than or equal to the largest element of the array. But what if you do include the largest element? Then also no problem. Let's say you take A3 and AN. Let's say you take A2 and AN. Let's say you take A4 and AN. So A4 plus AN should be greater than or equal to what? A4 plus AN should be greater than or equal to max of the rest of the elements, right? Max of the rest of the elements. Max of the rest of the elements. Simple thing. No, nothing complicated here. Okay. So what is the max of the rest of the elements? It's A2, it's A1, A2, A3 till AN minus 1. So AN minus 1. So you want A4 plus AN should be greater than or equal to A of n minus 1. But do you know one nice thing, bro? The nice thing is that AN is already greater than or equal to AN minus 1. And all the numbers are positive or greater than or equal to 0. An is already greater than or equal to an minus 1. So this is already satisfied. This is already satisfied. So basically, any subset you take where the last element is there, it will always be valid. You take any subset in which an is involved. That subset sum needs to be greater than or equal to a of n minus 1 or a n minus 2. That will is always true. That is always true, baby. That's always true. So this is also A4 plus AN is also a subset whose sum is greater than or equal to AN, na? Because you're adding some extra things in AN. और if only AN you take, that is also greater than or equal to AN. मतलब घूम घुमा के बात ये है कि आप कोई भी सबसेट चूज करो, उसका सम अगर AN या AN से बड़ा है तो वो वैलिड होगा, नहीं तो नहीं होगा. 100 बात की एक बात. If your sum is coming strictly less than AN, it means AN is not included in the subset for sure. And it will not be greater than or equal to n, then it's fail. But if the sum of the subset, whether or not an included or not, if it is greater than or equal to an, then guys, the job is done. Guys, right? Yes sir, clear sir, nice observation, clear. If you understand that the full problem boils down to this thing, ये सब ऐसे कंफ्यूज करने के लिए लिखा, तुमको डराने के लिए लिखा था. Solution is find the number of subsets whose sum is greater than or equal to y. This is a standard DSA question now. You just had to boil it down and decipher it. Okay. So write clear sir, yes sir, if you're understanding what's happening. All the people in the pro group and nice observation and things like that, start writing. This basically means that you just need to find the sum of subsets whose sum is greater than or equal to y, and nothing else you have to do. Rest is all going good, all going great, no problem at all. You're enjoying your life. If you have done even the basic questions or enjoying it like anything, it's just a pick, not pick knapsack DP version, where you have to just find the number. So now let's go ahead. Is greater than or equal to y. So guys, what is the standard DP trick? Well, I'm going to rush it in this video because I assume you have done the prerequisite course. If you have not done it, go and do it and then watch this video again. So guys, now listen to me. DP of what? DP of ij. If you just make DP of I, guys, it is not enough. DP of I will just tell you the number of valid subsets, sum greater than or equal to y. But you will not be able to make a formula because the y thing is varying. For each subset, sum is different. So you need to, necessity is the mother of invention. So in dynamic programming, in this case, you cannot just use DP of I. Because if you just use DP of I know I have taught you like this, right? That you make this big array in your mind from 1 to n. Then this is the index I. You define that dp of I is the answer to your question if you consider everything from index 1 to I. So in your case, dp of I would mean what? The number of valid subsets which exist in the array from index 1 to I, and dp of n would be the final answer. But this is not enough. You cannot find the valid subsets from 1 to I whose sum is greater than or equal to y. You cannot use direct formula. But what you can do is you can make dpij. You need to keep track of the sum. You need to keep track of the sum. So dp of ij. Guys, can you start writing in your pro groups what will be the definition of dpij? Well, it's very easy, you know, na? dpij, very easy thing. dpij basically means number of subsets from index 1, number of subsets from range 1 to I whose sum is j, whose sum is equal to j. Look, life problem easy now. Whose sum is equal to j, sum is equal to j. Okay, so that's what I wanted to tell you people, that the number of subsets from 1 to I whose sum is j. So let me test you. Are you guys knowing or understanding? Like 1, 2, 3, 4. Let's test the Kumar K student brain. So guys, after multiple years, after decades, research will be done on Kumar K students' brain quality. Because Kumar K students, whoever came, all got selected. So scientists got very interested in this thing. So guys, you need to make sure your brain quality is very good. Okay? Because in the future, people will be interested in you. Because you're a Kumar K student, right? So guys, prove me your brain quality. Tell me what is the meaning of DP45. I want meaning, I don't want the answer. Final answer is never important. The meaning and procedure is important. Start writing in your pro DSA groups. Mean for this array DP45 का मतलब क्या है? DP45 means number of subsets in the range 1 to 4. In the range 1 to 4, obviously from 1 it starts till 4. This means that only, na? Number of valid subsets in this much parts whose sum is 5. Start writing this in pro group so I feel satisfied. So let's see what the students are doing. Okay, number of subsets. Yeah, you guys are doing it right. Great job. Nice. Awesome. Good job. Now, so number of subsets whose sum is 5. Guys, can you all tell me how many subsets are here whose sum is 5? Can you guys please tell me that here how many subsets are there whose sum is 5? There are, okay, I will wait for you people. How many subsets are there whose sum is 5? Kaushik, you have to write it clearly. It is the number of subsets from index 1 to 4. I am using one based indexing whose sum is 5. DPIJ means the number of subsets whose sum is j. Okay. DP45 means number of subsets in this range whose sum is 5. Guys, now tell me DP45 ka answer. No one is telling me this. Right? DP45 ka answer in beta profile group. How many subsets are there? I can see 2 subsets. Tell me which are those 2 subsets, guys. Do you guys know which are those 2 subsets? It is simple. It is 1, 4 and 2, 3. See, their sum is, I hope you know subset means you can select any random elements. So there are 2 subsets. One subset is 1, 3 and the second subset is 2, 4. Please know, subset doesn't mean that there should be 2 elements. Even a single element is a valid subset. Even 3 elements are a valid subset. But in this case, only 2 elements are, when you sum up 1, 3 and 2, 4, like 2 pair elements, it's giving the sum as 5. So DP45 is 2. So guys, now we boil down to the creation. How will we create this thing? For this array only, let's try to find some smaller things first. Okay. So if someone asks you for the previous array 1, 2, 3, 4, 1, 2, 3, 4, what is dp of, it's a very basic concept actually. What is dp of 2 of 2? How many subsets are there if you consider only this much part of the array? You consider only till index 2 of the array. How many subsets are there in this part whose sum is 2? There is only one subset, right? 2. So dp2 of 2 is what? 1. Someone comes up and asks you that how many subsets are there till index 3? Okay, sir. Whose sum is 5. There is one subset 2 plus 3. How many subsets are there till index 3 whose sum is 1? The answer is 1. If you consider only this much part, which subset has sum 1? Only this one element. This subset has a sum of 1. I know you guys are enjoying it a lot. Now listen to me very carefully. So this is also 1, right? So this thing is done here. Now listen up carefully now, okay? So now, once these things are done, guys, I will teach you now how to calculate dp4 of 5. Okay. dp. Okay. Yeah. So, guys, someone is asking you now dp4 of 5. First, you write the answer for basic numbers and then you try to calculate dp45. dp45 means if you consider this full array, how many subsets have a sum of 5? But, guys, there is a trick. dp45 is always equal to two options. One is what? dp35. Now think why is this correct? I am saying that dp45 will always be equal to dp35. dp45 का क्या मतलब है? dp45 is asking how many subsets are there in this red part. How many subsets are there in this red part whose sum is 5? How many subsets are there in this red part whose sum is 5? This is nothing but equal to the number of subsets in the blue part whose sum is 5. If you go only one index back, still there will be so many subsets whose sum is 5, right? They are also included in the range 1 to 4. Whatever is included in 1 to 3 is also included in 1 to 4. So guys, my hypothesis says that dp45 is always equal to dp35 plus something special. सो गाइज मेरे कहने का क्या मतलब है? मेरे कहने का ये मतलब है dp45 का आपको मतलब समझ गया. मतलब 1 से लेके 4 के इंडेक्स में ऐसे कितने सबसेट है जिनका सम 5 आता है? मैंने बोल दिया 1 से 3 में जितने भी सबसेट थे ना जिनका सम 5 आ रहा था, वही इसमें भी इंक्लूड कर दो. व्हाई? dp35, राइट? dp35 इज व्हाट? 1. dp35 1 का मतलब क्या था? 2, 3. So 2, 3 is a subset from 1 to 3 whose sum is 5. But this is contributing to dp45 also, na? In dp45, this much part also 2, 3 is there. So 2, 3 is originating from dp35. That's why I'm writing dp45 equal to dp35. Basically, I'm trying to say that dpij is always equal to dpi minus 1j. मतलब अपना भार पीछे चिपका दो. The number of subsets, the number of subsets whose sum is j from index 1 to I is nothing but equal to the number of subsets whose sum is j from index 1 to I minus 1. In this case, you have not included I. You have not included the element 4 in your subset sums. You are only bothering about the previous index numbers. When you are at 4, you are only bothering from 1 to 3. So one of the ways is dp45 is dp35. But guys, what if you try to count the subset sum where the last index I is forcefully included? 4 is forcefully included. If you put 4 in the last part, guys, what will be required from this blue part? If you forcefully you are trying to find a subset from 1 to 4 whose sum is 5. You are saying, okay sir, let's include the last element in our bag. If you include 4 here, you want a 1 here, no? Then only the sum will be 5, right? If you force from index 1 to 4, you want a subset of some 5. So you forcefully include the last element whose value is 4, okay? So you forcefully included it. Now, You want to see, is there any subset with sum equal to 1 in this white part? अगर तुमने लास्ट वाले इंडेक्स का 4 अपने थैली में डाल दिया है तो अब तुमको आगे वाले पार्ट से 1 चाहिए ना, क्योंकि 4 डाल दिया तो 4 के साथ क्या ऐड करोगे तो 5 आएगा, 1. So from this white part you are searching for 1. White part is what? White part is dp3 of 1. How many subsets are there in this white part whose sum is 1? They all will bond with this 4 and generate the subsets of sum 5. What a great trick. So dp45 is nothing but dp35 plus dp31. So if this is array B, what will be the formula? dpij is equal to dp. This is now basic stuff for you. dp. In case you are not understanding what's happening, please go and watch the dp prerequisite course. dpij is nothing but what? First, you put the blame to the previous index, all the subsets till I minus 1 whose sum was j plus. If you forcefully, here you like excluding the element I और यहां पर इंक्लूडिंग द एलिमेंट आई, तो अगर एलिमेंट आई इंक्लूड किया है, दिस वाज बी एरे राइट, बी ऑफ 4 वाज 4 राइट, सो बी ऑफ 4 वाज 4 राइट. राम राम. So if you're including this guy, then you will be searching for what in the right part? The total which you want is 5, right? So you will be searching for 5 minus 4. 4 is nothing but b of 4. 5 minus b of 4. Samjhe? If you're trying to make a bag and the last element is what? B of I, and you want the total sum to be j. So the starting element needs to be what? You want the sum of this bag to be j, and the last element is bi, so this will be j minus bi. J minus bi plus bi will be j. So from this part you want a subset sum whose sum is j minus bi, because bi is already taken here, so bi plus j minus bi will be j. So dpi minus 1 j minus b of I. You must have done this in basic knapsack dp, including element I. Okay, so you understand these things, right? So that's it, guys. That's the formula. So, guys, what will be the final answer? I will talk about it. Before that, let's go to the code, guys. You can see in my code, like all the array elements, size of the array is still 5000, and all the elements in the array, the sum of them will always be less than equal to 5000. This was mentioned in the interview. So vector LLDP n plus 1, you can see 5000. DP001, what is the meaning of this? This is the base case. I'm using it because it will help me when you check the formula, you will be understanding it. Okay. So DP0 comma 0 equal to 1 means if you don't travel the array, this is index 1, right? Is there anything before index 1? No. So this is what? Nothing. Nothing means what? 0. dp0 of 0 means, is there a subset of some 0 when you are not going through the array? Yes. Empty space is also a subset, right? So dp00 equal to 1. Now how does this helps us? You can see it here. First of all, dpij equal to dpi minus 1j. Okay. So for all dpi0 will always be 1. dpi0 means if you consider the subset from index 1 to I, is it possible to get a sum of 0? Yes. How? Don't choose anything. Empty subset is one subset. That's it. So why am I doing this? Because dpi0 can be required in this formula. dpij is what? dpij plus dpi minus 1 j minus b of I. What if j is equal to b of I? Then it will be dpi minus 1 0 na. So this 0 should be contributing to 1. Why? Like अब मैं आपको बता देता हूँ कि ये जो हमने किया like 1 2 3 4. ओके, समझो अब तुमको कोई पूछता है इधर dp44. Okay, so dp44 is what? The number of subsets in this range whose sum is 4. So you will write what? It is nothing but the number of subsets till index 3 whose sum is 4 plus the number of subsets till index 3. If you include this forcefully, then you want a 0 in the start, right? 0 plus 4 to be 4. So number of subsets till 3 whose sum is 0. So dp34 will be what? What is the number of subsets till index 3 whose sum is 4? 1 plus 3, there is one subset I can see. So this will be 1. dp30, is there any subset here till index 3 whose sum is 0? Yes, empty subset. Why? You take empty subset here and this 4 gets added here, right? J minus b of I. So empty subset plus 4 is nothing but 4. So 4 also got counted here. This one contributes to only 4. And this one contributes to 1 comma 3. I know no one explains this in this much depth, but I hope you understand. ये dp30 की जरूरत क्यों पड़ी? ऐसे ही dp20 की जरूरत पड़ेगी, dp10 की जरूरत पड़ेगी, dp00 की भी जरूरत पड़ेगी. ऐसे मजाक में नहीं लिखा है. So guys, that's it. Now guys, what will be the final answer? Everyone needs to write in the pro group. So you know this is the array given to you. Let's say you have calculated dpn1, dpn2 till dpn of 5000. What will be the final answer? dpn1 is nothing but the number of subsets in the whole array whose sum is 1. dpn2 is nothing but the number of the subsets in the array whose sum is 2. What did we want? We wanted the number of subsets whose sum is greater than equal to y. So final answer will be dpny. Ny means if you consider full array till size n, how many subsets are there whose sum is y, plus how many subsets are there in the array whose sum is y plus 1. You have to consider each sum which is greater than equal to y, where y is what? Y is the first, you will find the maximum element of the array which is y. Then final answer will be what? dpny plus dpny plus 1 plus dpny plus 2 plus I hope you got the point, dpn till 5001. This is the final answer. You cannot just say dpny is the final answer, because dpny only tells you the subsets, count of subsets whose sum is y. What about the count of subsets whose sum is y plus 1? That is also valid, na? Count of subsets whose sum is y plus 2. All those subsets have their sum greater than equal to y. That's why. Clear? React with emojis and tell me if these things are going inside your brain. So hello guys, Ram Ram. If you want me to post the video recording of the follow-up 1 and follow-up 2 of this 75 to 85 lakh CTC Atlassian SDE-2 interview problem, do let me know in the comments. If you want, I will post it. Also guys, one more thing, if you are someone who really needs my personalized one-to-one mentoring, personal help and personal training, please do check out the program link, because I am very passionate about it and I help my students as much as I can. Okay, Ram Ram.